Hi, and welcome to my first YouTube channel. My name is Patrick Chong, and I'm creating this YouTube channel to document my journey as a software engineer. I've been working in banking for the last 4 years for HSBC, and I'm now transitioning into software development. And I wanted to document this journey to show everyone out there that it's possible to transition from whatever job you're doing. And if you're passionate about coding, then this is a real possibility for you. As the title, I'll talk more about the transition towards the end of this video and the 2 offers that I am currently considering. But more about that later. As the title of this video suggests, I'm going to go through the 10 most asked questions at my software engineering interviews. So I've interviewed at over 50 different companies. So some were fintechs, startups, VCs, others were banks, some sustainable finance companies. All of these interviews have been very similar, and there have been some very common questions asked at these interviews. And so anyone preparing for a software engineering interview will probably find this video very helpful. And for those of you who don't want to sit through every question, I have included a timestamp in the description with the 10 questions. And for those of you who just want to skip through and look at what the 10 questions are, please feel free to do so. But I'll be going through each question in relative detail and how I answered it during these interviews. So the first question that I was asked repeatedly across sort of the companies that I've interviewed for is around object-oriented programming. And it's basically this idea that there are data types, things like integers, strings, booleans, so on and so forth. But there are certain things that you can't really describe using a data type. And for example, if you wanted to describe an organization and its employees, you couldn't really describe it using a data type, right? And so you need a structure to describe this organization and the employees that work for it. And the structure that we'll use is called a class. So a class is something that you want to describe. For example, let's say you want to describe a company and its employees, right? You couldn't really use a data structure to describe it. And so what we do is we create a class. And in our case, a class, we create a class of company because that's what we want to describe. And so within this company, what did we say? We want to describe the employees within the company. And so we can describe the employees in a lot of different ways. So it could be their age, their salary, their hair color, their clothes, the color of their clothes. So and I'm coding this in Python, but the idea is the same in any coding language. So you've got their age, let's say their height, their salary, and let's just say clothes, right? Just zoom out, right? And so you don't need to worry so much about the syntax. I can describe it in another video, but what you do need to know is the overall structure. I'll write down here in comments the important parts that you really need to know. So the first thing is the class, which in our case is a company, what we're trying to describe. Then you have objects, and hence object-oriented programming. And our objects are the employees, is what we're trying to describe within the organization. And then we have attributes. So attributes of these employees, right? And in our case, the attributes are the height, the age, the salary, and the clothes. And so these are ways of describing the employee which sits within this class. And so you wouldn't be able to do that with data types. So we've learned the class, the object, and the attributes. And so sometimes you also want to do something to the attributes. So you might want to give an employee a raise after they've worked for a company for 6 months. So we can create a object function, so called raise salary. Right? Salary after raise is equal to self salary, so the original salary 1.25. So let's say we're giving them a 25% raise. And so the third thing that you really need to know is what we call an object function, or a method. And that's another way to sort of describe this employee, or rather the attributes of the employee. And these are really all you need to know in terms of the structure of object-oriented programming. You need to create a class, and in our case this is the company, and within that class you will have objects which you want to describe, which in our case is employees, and then you'll want to have two ways to describe them, which is the attributes, so in our case age, height, salary, and clothes, and you also want to create an object function where you can do things to these attributes, like give an employee a raise. And that's all you really need to know when it comes to object-oriented programming in the sense of the structure. Now, one other thing that you do need to know are the benefits of object-oriented programming. And there are four key things that you need to know when it comes to the benefits. So the first one is inheritance. So inheritance is quite simple, and it again goes back to this idea of using classes. So imagine you've just written a function for a specific class. Let's say you've just written a class for the company that we've just discussed. And you've written this class and you've described employees, their age, salary, height, and let's say that list is very, very long, right? And now let's say you want to describe another company, a different company to the one that we've just described. Well, normally you need to rewrite the whole class, right? You would need to, because another company would typically have employees with similar attributes. They would all still have an age, they would all still have a specific hair color, they would all have a specific height, so on and so forth. And so there's going to be a lot of overlap with the first company that we've just described in the class. And so instead of rewriting all of these attributes, what you can do in this new class that we're creating to describe the new company is we can inherit from the first class. And so by inheriting from the first class, you are avoiding having to rewrite all of that logic and attributes, and you can just use it when you create your employee objects, right? The benefit is to create cleaner code, so you're not repeating yourself over and over again, just like I've described. And so number two, the second benefit is polymorphism. And what does that mean? So polymorphism is the idea that you can use keywords to describe different things. For example, in Python, you have the addition symbol. Now, when you're adding two integers, you are just adding the two. If you do 2 plus 2, you get an output of 4. But at the same time, you can use the same addition operator to add two strings and to concatenate them. And what does that mean? It means that you're basically joining the two strings together. You're doing two very different things. One, you're adding numbers together. The second one, you're joining strings together. And so you can imagine there are two very separate operations that you're doing, but you use the same plus sign to achieve these things. And so that's the idea behind polymorphism, where you can use the same operator in different instances to mean different things. And the benefit of this is that you don't need a million different operators to describe or to do different things. You can have a very small list of keywords or operators where used in different scenarios will help you to achieve different operations. And so that's benefit number two, polymorphism. The third benefit of object-oriented programming is abstraction. So abstraction is where the program hides from the user some of the back-end logic of the code. So if you watch movies where there's code involved, usually there's a lot of zeros and ones. Usually it looks very, very complicated. And that's not to say it's any different in real life, but what's different is that software developers generally hide some of the more complex code that the user doesn't need to see. And a very good analogy is if you take a car, for instance. People driving a car don't necessarily understand how the mechanics of it works together, but they will understand how to drive the actual car. And they won't even need to look under the boot unless something's wrong, of course. But then even then you send it to a mechanic. But the point is, the driver of the car doesn't need to understand or even see how the logic or how the different parts interact with each other. All they need to know is how to drive the car. And it's the same in coding. The user doesn't really need to know the back end, the code. They just need to know how to play the game or how to sign in to a particular blog or whatever that application is, right? So, and that's abstraction, where you can hide the complex concepts and the user can just see the very pretty front-end interface. And then the fourth and final benefit of object-oriented programming is encapsulation. And encapsulation basically means that you are protecting your class, and specifically the variables in your class, from being modified. So if we go back very quickly to the class that I just defined, you will see that there are various like the age, the height, the salary, and the clothes that I've just defined. And who's to say somebody couldn't come into this program and change, for example, the height to, let's say, weight, right? And if they change that, when you create the objects, which are the employees, and when you call on height or when you call on weight, it will show you the height. So it doesn't quite work out, and somebody can basically jump into your program, make changes, and hack your system or do things that you wouldn't expect it to do. And so to protect your class, you can use encapsulation. And the idea of encapsulation is that you can change the access modifiers from within the class. That just basically means that there's 3 views that you can set the variables and the functions from within your class. The first one is public. So public meaning that anyone can jump into the program and change things. The second one is protected, and protected basically means that you can only access the variables and functions in your class from another class that's inheriting from it. And remember, I described what inheritance was before. And the third access modifier is private. So in this case, you can only access the variables and the functions from the class where it was defined and created. And that's very powerful because it gives you an extra level of security, knowing that people can't change things that's existing in your system. And there you have it. Those are the 4 benefits of object-oriented programming. And so just to recap, what you need to know within object-oriented programming is the structure and also the benefits. So now let's move on to the second most asked questions that I've come across from my 50+ programming interviews, and that's regarding version control. And for those of you who have already done some software development work, or those of you who have built your own projects, I'm sure you've come across Git or GitHub or GitLabs. And what that is basically a distributed version control. And it's a way to store your project or update your project as you're working on the project. So imagine you have a whole team that's working on a project, right? On, let's say, a PowerPoint presentation. And you save it in a common drive where everybody can access it and save it down onto that drive. And if 5 of you are working on that project simultaneously, all at the same time, and you all save down the same version, what's going to happen? Is the latest version going to reflect the saved down version of all 5 people? Well, of course not. It's going to only reflect the changes of the last person who's saved it down. And that can be a real problem because you don't capture the changes that all the other 4 people within the team have made. And so that's where Git or any version control comes in. And it's a way for you to save your projects in a common place that is very clever, because even if 5 people made changes at the same time to a document and saved it down all at the same time, or roughly at the same time, Git will understand this and it will reflect all of the changes made by all of the teams. And that's why version control is very important, especially when it comes to software engineering roles, because you're bound to use it when you do your work or when you work on projects at your company. So then the third most common question I've been asked from these interviews is around testing. So there's 2 main topics of testing that I've been asked. The first one is unit testing and the second one is backtesting. Unit testing is simply testing individual bits of your code. Now you can imagine if you've written a very big function that does a lot of things, or you've written multiple functions from within a class, just calling on each sort of individual function and testing and seeing what the output is when you put in different inputs is called unit testing. And it's a way to isolate where the error or the bug is coming from. It's a way to very quickly see which parts of your code is causing the error, basically. And so that's unit testing. And then we also have backtesting. And that's basically where you take historical data and you put it into your function and see whether it does what you expect it to do. So for example, if you built a trading bot which takes in the, let's say, live data and buys and sells the specific asset or crypto, then one way to check whether or not your strategy is working, not to say that it's making profit, but whether it's doing what you intend it to do, is to throw in historical data. So let's say you created the strategy where you would buy Bitcoin every time the price of Bitcoin changes by 20%. If you just start implementing that strategy to live data, you don't know whether or not it's buying or selling every time Bitcoin changes by 20%, right? But if you feed in previous data, you can kind of track every time the price of Bitcoin has changed by 20%, whether or not the bot is buying the Bitcoin. And so backtesting is a way to take historical data, plug it into your function, and check whether or not it's doing what you intend it to do. So then the fourth most asked question that I've come across is the difference between iterators and generators. And so the difference between an iterator and a generator is that for items in an iterator, they're stored in your computer's memory, meaning that you can access the elements over and over and over again, for example, by using a for loop. Whereas with a generator, you can't really do that. It's not stored in your computer's memory, and so you can only access the items one time. So if you were to use a for loop to iterate over a generator, you could iterate over one time, and the second time you couldn't iterate over it. Let's take a look at a very simple example. And so here I have set up a list. So I've called it list array, and you have a list with elements 0 to 4 in it. And I've simply written a for loop that loops over this array. And so if I run it, you will see that we get the numbers 0 to 4 as expected. And now let's try looping over the array a second time. And as you'd expect, if we run it, you get 0, 1, 2, 3, 4 for the first for loop, and then you get 0, 1, 2, 3, 4 for the second for loop, right? And now let's take a look at a generator. So I've created a generator variable, and this is the syntax of a generator, right? You've got the curly brackets together with like list comprehension. And so again, let's run this. So I use a for loop to run over the generator. I get the numbers 0 to 4. But now when I loop over it a second time, when I click run, and nothing happens. And that's because, as I said before, you can only use the elements of a generator one time because it's not stored in memory. And the benefit is that if you're dealing with a huge amount of data and you don't really want to store all of that data on your computer or in memory because it takes up a lot of space, then you can just use a generator where it will generate each item one time and you can do whatever you want to it, and then it gets thrown away. And that's really the benefit of using a generator versus an iterator. You just use it one time, it doesn't get stored in memory, and it doesn't take up as much space. So let's move on then to our fifth most commonly asked question, which is the Lambda function. And the Lambda function is also known as the anonymous function because it can take an unlimited number of variables, but with one expression. And I've put together a very basic example. So here I have the variable x to represent our Lambda function, and then the syntax is lambda followed by 3 variables a, b, and c. And let's say you wanted to add 3 random numbers together, right, over and over again. So what you can do is you can create this Lambda anonymous function, and then you can, this is the syntax for it. So you have x, which is the Lambda function, followed by the 3 sort of variables. And if you print this, you'll see that you indeed get 6. Right? And so that is the Lambda function in a nutshell. It's not too complicated, but what you should remember is that it takes an unlimited number of variables with one expression. And in our case, the expression is adding the 3 numbers together. And you can write very complex expressions, but you can only have one expression for your Lambda function. So then moving on to the sixth most commonly asked questions, it's around threading and multiprocessing. Now, for those of you who haven't come across those terms, it might seem a bit daunting, but it's nothing too complicated. So threading basically means that there are a lot of times when your computer does work that involves waiting around. So if your computer is downloading a very large file, it might take a minute or a few minutes to download. And in that time, your computer can be doing a number of other things. And that's basically threading. Whenever your computer is doing certain things that involves a lot of waiting around, like pulling data from an API or waiting for data to be pulled in. And what we say is that your computer sleeps. And during this sleeping time, whether it's even 1 second, your computer can be running other scripts. And 1 second might not seem very long, but the computer can do a lot of things in that 1 second. And that's called threading. Very similar to that, we have multiprocessing, which is similar but not the same as threading. So with multiprocessing, your computer doesn't necessarily need to sleep. And your computer can run lots of scripts all at the same time, which makes it very cool. And the way it works is that your computer divides all these scripts or all these tasks into different processes, and the computer has a very clever way to split up these tasks into different processes and run them all concurrently or at the same time. And so basically threading and multiprocessing is a way to speed up the tasks and the scripts that you need to do. And the main difference between threading and multiprocessing is you would use them in different instances. Like I just mentioned, when your computer deals with problems that involve a lot of waiting around, and we call these tasks IO-bound tasks. They do a lot of waiting around or sleeping. Whereas if your computer does a lot of processing or your computer needs to do a lot of work for specific tasks, you wouldn't use threading because it wouldn't really help it. You would use multiprocessing because you can process all of these tasks at the same time, right? And you wouldn't use threading because there's not a lot of waiting around. And so you would use multiprocessing on CPU-bound tasks, tasks that take a lot of processing to do. And so that's the main difference between the two, and those are the instances when you use one versus the other. And in interviews, the interviewers are unlikely to ask you to code out threading or to code multiprocessing. But there's a number of tutorials on YouTube that you can watch and get a very basic fundamental understanding of how you would code them out in different examples. Now, they might ask you for examples of when you would use threading versus when you would use multiprocessing, and I've just mentioned a number of examples, like when you're pulling data from an API for threading, or for multiprocessing if you are re-imaging a number of images, which takes a lot of computer power. And so you can use multiprocessing to re-image a number of images all at the same time. Next up, at number 7, we have decorators. Decorators have come up a lot in some of these interviews. And very often you're asked what the function of a decorator is. Why would you use a decorator? And it's really quite simple. So if you have written, let's say, a very long function that does a lot of things, and you wanted to add additional functionalities to this function, rather than changing the original code or code that you already have, you can use decorators to add additional functionalities to this function. And the benefit is, if you wanted to alter your original code, this code might link to other bits in your system. And by changing it, you might create errors or you might create unintended consequences. And so rather than changing code that's already existing in the system and already working, you can add functionalities by adding a decorator. And in this way, if after adding the decorator and this additional functionality, if something goes wrong, if you get an error or a bug, you know what's causing it. And so it's a very clever way to add functionalities on top of your existing function without changing the original code. So then the penultimate, the 9th and second last question is around your CV. Now, this might be a bit more generic, but very often interviewers will ask you details about projects that you've put on your CV. especially if you haven't had extensive experience in software development. You would have probably created a number of projects and put them on your CV. Now, some of these projects you might have created a few months ago, others you might have created a few years ago. But it's very important that you understand your projects and what you've done and used them for, and how you've built your projects. Because when an interviewer asks you about certain aspects of your projects, it's not good enough to say you built it a while ago and you don't remember. Because if you've put it on your CV, you need to remember, and you need to really understand how you built your project, what your project was used for, and how certain components within your project work. And that's very, very important. And if you can't answer those questions, you will definitely lose credibility when it comes to the interview. And so the second last question, and I would really emphasize this, is know your projects inside out and how you built them and all of the dependencies that you've used to build the project. And so then the final question that I've been asked a lot is around data structures. So the type of questions that I've been asked around data structures have been either in the form of a question. So the interviewer would give me a question and ask me to solve it. And very often you would need to pick one of these data structures to solve the question. And the question would be organized in such a way that using certain data structures would be a lot more beneficial than using other ones. And in other cases, I was just asked what the differences are between certain data structures. For example, what is the difference between using a list versus using a set, or using a list versus using a linked list. So with a list, for example, you have random access to elements, so you can very easily find an element and pick it out of that list. Whereas with a linked list, you couldn't do that. You would need to start from the beginning and sort of move along the linked list until you find a specific element. And it's questions like these that I was asked in interviews. And to summarize, there are two main questions when it comes to data type. First one is where the interviewer would give me a problem and ask me to solve it, and I would need to identify and use the correct data structure to solve the problem. And the second type of question is basic questions around the benefits and drawbacks of using certain data structures when you compare them to other data structures. So there you have it. Those are the 10 most asked questions that I've come across after interviewing for over 50 different software engineering roles over the last 2 months. And as I mentioned towards the beginning of this interview, I have just moved from banking and I have received 2 offers, one from RBC, the Royal Bank of Canada, and another one from a fintech called BMLL. And I'll be making a decision on which one I'll be taking on within this week. And so I think this is a very exciting time for me. And I'll be continuing to make these YouTube videos because I found that I really enjoy sharing my knowledge. And for those of you who have found this video very useful, if you could drop a like and subscribe to the channel, it would help out a lot. And if you have any other suggestions on what you'd like to see or what you'd find helpful, please leave a comment in the description. And for my next few videos, I'll be going through a number of projects that I've found very useful. And for those of you who are writing up CVs or looking for projects to create, I think the next few videos will be very helpful. So until the next video, take care, stay safe, and thanks for watching.